Hello everyone, my name is Wahid Lutfi. I'm going to share my screen first, and then I'm going to just show you what I'm going to cover tonight. Basically, I'm going to cover Microsoft Windows 11 with Python, IPython, and Jupyter Lab. All together, we're going to discuss those ones. So as you can see, I'm already on Python website, which is python.org. And I have also visited the website for Jupyter Lab, which is this one, Jupyter Lab, and then also on IPython, as well as Microsoft website. And for each of these websites, I mean, there's tons of kind of information, data, and everything that you can just take advantage of it and start learning it, and tutorials and documentation, modules, and everything that you can download. As you can see, there's a lot of it. And then just for the documentation under Jupyter, there's a Jupyter project that you can get all the documentation as well here. So the information is a lot there. It's not like you're missing anything here. There's tons of documentation. Similarly for the python.org under documentation here, you can get it. And then I went and download Python already on this operating system. So let me just show you my desktop, which is Windows operating system here. This background is the Windows 11 desktop. So if I right click here and open a terminal here, open a terminal, you can see that it opens a PowerShell terminal. So if I just write a system info information type more, then it's going to just show me that I have the Windows 11 Microsoft Pro, and then the build is 10.02, and this is the build version. So I have about 32 gigabytes of memory. I can also get this information with other commands as well, but I don't need to, just since we already showed you in a number of other videos those information with system information, searching with a fine string, and then particular one that we are looking for, you can get that one. In addition, the only other aspect of it is that I'm going to, as you can see on my background, everything is there. In addition, I could open a command prompt like the one that I did here with terminal. I could also type in CMD here and then open a command prompt. And the command prompt will just be on Windows. It already tells me the build version, that is Microsoft, again, system info, and then find a string /I, and then look for example, OS name. And that is just telling me that I'm running Microsoft Windows 11 Pro. And then if I just want to know how much memory I have, I could type in memory for searching for memory. Here, mem is good enough, and it will tell me 32 gig. And if I want to know the model of my processor, it's Intel 64-bit, and then you can see i7 at 3.4 gigahertz speed of it. So clearing my screen here, I could just say which version of Python I have. Python -- version, you could see that I have 3.10.11. And I could also get with -v, the same thing. And similarly for IPython, I could just see what version I have, -- version, you could see that I have 8.12.0. And similarly, if I want to see for Jupyter -- version, Jupyter is going to show you the entire core packages, which is IPython and every other packages that are listed here. They're all going to be shown with the version that are there, because it's the Jupyter core packages. that are coming with Jupyter. And so inside here, you could run like Python and -- help would give you all the help in there. IPython -- help would give you help on it, and then clear screen and Jupyter and -- help will give you the help. So since it's more information on some of them, like this, you could just do 5 more and then you just read one screen at a time. But the Jupyter Lab, that was just already smaller and then information there, you could do that and just get it on one screen. So knowing that Jupyter is available, IPython is there. Now the version we already checked, how do you get into Python? You could just type in Python itself and then exit out here, or just type Python 3. It will just get there because the same binary version, Python and Python 3 are pointing to the executable for 3.10.11. So how do I know that one? I could just say Python here and then say import sys and then sys.path is giving me the information sys.executable, and then executable will tell me Python 3. And if I exit out of this one again, say go to Python 3 and then just say import sys and then sys.executable, you will see that the Python.exec is the executable here. And then similarly, it says .platform to see that it's a Windows 32 for the platform of this one. And then also, if I just quit out of this one, with the left parenthesis, right parenthesis, you type in quit or exit, it's the same thing. It kicks you out of the Python interpreter. So this Python interpreter is also called IDLE, Integrated Development Learning Environment. The 3 greater sign is the prompt for it. So normally if I just want to say, for example, get me a list of all the directory inside Python, it will tell me that this is Python stuff that you have. And then these are the _magic method or dunder method that are there. Each one of them are pointing to a doc string or built-in method. So if you just want to get help on Python, you just type in help with this left parenthesis, right parenthesis. Now you're inside the Python and there help. Then you type in topics, topics, and then you get all the list of topics that are available. If you're looking for list data structure, just type in list. Notice that the name is case sensitivity is important. So whatever is the case, you just do that one. If you type in topics here, topics there, and then if there's a list called class, then classes or there classes, you could just get information on the classes. And then some operator like plus symbol or multiplication on all these operators, once you look for one of them, and all of them are available for you. So whether you type in plus or multiplication, it will give you the same kind of help there. And then the keywords, you can also search by keywords, all lowercase keywords. And then you can see the if statement, for statement, while statement. So if you say if statement, give me the syntax for if statement, give me the syntax for while statement, give me the syntax for statement. Each one of them that you get, the information is going to show you here. So as an example, if I just get out of here and I just say press enter here, it's gonna take me back to the Python IDLE or interpreter. So if I just say import OS here and on os.system, I want to clear my screen, so I go on the top of the command prompt. Here, if I just say just run os.system and then get that system information from here, system info, and then find a string /i, and then OS name. So the same information that we run there, you could put it here, and notice that I use a single quote here because I wrote OS name in double quote. So when you do that one, it will just work for you in that sense here. And then the other thing that I want to do is, let me make this screen a little bit smaller, so that way it fits better, because some of the Zoom is just hiding and blocking some of the fonts for my eyes, and I cannot see it through. That's why sometimes I type it in uppercase when I meant to type lowercase. So here I'm going to show you the other related things that you can do with OS module or with Python libraries or math function. So the interpreter itself, you can do like a lot of computation, 2 times 8 or 10 divided by 5 or 10 mod 2 and then 10 mod 3 and the remainder is 1. The divisor, you can get that information, and then also you could just do math modules. So if you want to just use the math module, in addition to these kind of things like square root or power function or something, you need to import the math module. So you say import math. Now math is there. Of math, all these functions that are inside math modules is available for you. So now if I say print math dot square root of let's say 121, which is 11, then I could get that there. And instead of 121, if I say let's say 10,000, I believe I put 10,000, so 2 more zeros, and then that would say 100. That's correct for the square root. So if I just say, give me the power function, the power of something. So the power function is, you could say power of 2 to the power of 10, right? To the power of 10 is gonna just say 1024, and to the power of 11 is gonna be 2048. So assuming that you want something, you can also use methods that are inside this one is object-oriented method. So when you say math dot, once you put the dot, the methods and constant, the variables, everything, properties, attributes that are available for it, you can use. For example, we could just also do something like this. Let's say math dot, let's say power of 2 to the, and then this one I'm gonna say I'm gonna get the square root of math dot square root of 100. So this is also gonna give me same syntax that was earlier, that was done with 1024 here, because this one is going to give me 10 and then to the power of 10. So if I want to get like a square root of math dot square root of 25, which is 5, so that would just return one. I have to specify this one is 1 for this one and 1 more here. That's why the last time we had to type in this one here, because I did not close the last one. So when you specify the number of parentheses that you open, you just match it up with the other ones and you will get the result. So this is one of the way that you could do it. I'm not gonna go to each of those modules one by one, otherwise this video will be indefinite, and then we're going to just cover some part of some method and other ones, whether I jump in on IPython or Jupyter Lab to do that one. But I'm just going to show you in IPython and Python and Jupyter Lab, so you understand that you can do it in one, you can do it with everything else. The only difference between interactive Python, IPython, and Jupyter Lab is that it makes it much easier than the idle Python interactive. So if you're using the idle, you have to know the commands and you have to know the methods and the methods and magic methods, and then all the documentation, whatever you need, you can do it yourself. But sometimes the coloring and the maybe the tab delimiters, the sensitivity of matching all these method and providing you the parameters, and inside Jupyter Lab and IPython, it makes it more interactive and more easier to use those ones for developers. So I'm going to cover both, or all three of them. Here we did show you this. Now I told you that if when you import the sys module, sys.version, it's going to tell you the Python version. Sys.executable, let me write executable. It's going to show you actually sys.executable, like that. That is the Python executable. Sys.platform, it shows that is Windows Windows 32. It's actually 64-bit operating system. And how do I know that one? I could say, since the dir of OS is there, I can use os.system, and I could just say, let me clear my screen first and say os.system. I could say system info, and then find string /i, and then I could search for model, and then that would be the architecture of the machine, the processor, and that should show 64-bit processor and tell 64-bit right here. So you know that that is 64-bit. And then you can also run the OS in other platforms. So since we did the sys, I want to see the sys.ps1. PowerShell 1 is this shell. So notice that every time I write a statement here, it's going to just have the prompt as prompt shell 1 for the system. And then if I want to say sys.path, this is the path where all the packages for Python and other the Windows operating system and everything is set. So in addition that I say os.path, you can see the OS path is this, C colon this and tpath.python, that is set. At the same time, let's do one more thing here. I want to show you sys.ps1 and sys.ps2. Sys.ps2 is ... So notice that, what does that mean? The first one is this greater sign, which is this. And when you're going to a subshell, prompt shell 2, you're going to see this ... That's when you use a for statement or a while statement or if statement. It's going to just expect you to be nested into like a another section of code. So like, for example, I say for item in dir of sys.path, I want to just print dir of sys.path, whatever it is. I'm not going to actually do a dir on it. Let's just print all of those paths one by one, like we did here. Because it's a list here, you can see start of the list. So sub-0 would be pointing to this one, sub-1 would be pointing to this, and so on. So I'm going to go through this and say print item. Notice that ... As soon as I press this one, it's going to say the prompt shell 2 was pointing to that one. If I don't have any other statement, then I'm going to just end it. I could just say press enter. It's going to print that one by one. So if I just say sys.path sub-0, then it's gonna just give me the first one, which was like right here. And then sys.1.sub1 is gonna give me the second one, which is zip. And then sub2, you get the point. So right here, if I wanna just get all of them, I put this colon, and it's gonna print the same thing as sys.path. And if I wanna just say, start with 1 and then until 3, only get the first one and second one, you can do that one. And if you say -1 here to the last one, you can get that one as well. Missing the last one, actually, this last one, you have to just, whenever you do this one, the last one is not included. If you want the last one like that, you just do this, meaning that include everything. But starting from where? So if I start from the 5th one, this is the short one there. And that is for the sys module. And then I'm gonna say os.system, I'm gonna do a clear screen here. And then notice that when I do a dir here, these are objects that are loaded. The OS module is loaded, the sys module is loaded. So if I say import numpy as np, and in the numpy is not there. So numpy has not been imported. Now I need to just use the pip to find out if numpy is installed on it or not. So in order to do that one, you could just say os.system, run the pip command, and then run the list command, and then do a find a string /i, and then numpy. And notice that find a string and the other commands are your friend. So when you do this one, os.system, let me just make sure that I didn't have typo. Here, os.system pip list that, and then notice this one is saying that to update run pippins. When you run the pip information, it is going to just expect you to run this. I could just do the same thing inside the Python, but it would be more easier to just say, let's just open another terminal and then run that one on the other terminal, so we'll make sure that we install it. So I type in command prompt, and notice here that it's there, this information, but because that one requires a pip list itself, when you run it, it shows you that this is a pip list, and then clear a screen pip list, pipe find a string /i, and then numpy. It's gonna just say that you need to run this one, and then you need to be actually running the update. When I do this one, if it requires root privilege, it's gonna ask me to do it, and then some way in the middle, if I don't have the proper permission, it will just prompt it. But in this case, it did not require it, so automatically updated my system with pip. And now if I just up arrow here and then look for this one, it did not find numpy. But if I look for another module that is there, like maybe request, it's gonna show me the version of request that is there. So inside here, when I did the import, it did not work. So I could say import request as R, or just let's say import request itself, dir of request. And then you can see all the directory for all the things that are available, methods and everything. So inside request, you actually could just do a lot more to just work on a website and everything. And so we could just say, let's say os.system, run the clear screen here. Sorry, os.system, I'm gonna do a clear screen first. And then the dir of dir of request, it shows me that I can have all these methods. One of the methods that I'm interested is get. So I could just say URL is equal let's get the HTTP s colon. I'm gonna put my website HTTPS colon www. MyWebUniversity.com. That's my website. And then here, if I just say print URL, notice that URL is going to be printed. And that URL, if I just go there, basically it's going to take me to MyWebUniversity.com. Here, you can see, HTTP, let me just make sure I don't have typos here. Okay, so there must be some typo. I have maybe more than one www. There should be 3 of them. Yeah, there's was one more extra. So I'm gonna correct that one on the URL here, and then just put 3 www. That's why I see I'm sitting far away from my display, and then that was not setting it. Now, if I do a print here, you can see this is basically correct. And then let's just do this one. I'm gonna go to YouTube first, just to go to our YouTube channel. And then obviously there's a lot of other videos that are there. So if I go to mywebuniversity.com, you see that it took me this time. So now, what about this thing that we did here? This time I'm going to say R is equal request.get and then URL. The URL that we did, now r.ok status is okay. R.text is actually reading the entire page. And then r.content is going to read me in bytes, and that is there. So the entire HTML page is there. And then you look at the dir of R, the methods that are available. You see that text was available. R.url, you could see that it is actually this website. So then you could change that one to say, well, let's get the content of it to something else. And then 1 second, hold on 1 second, please. So this time we did the URL like that one. And you could also get like r.status code to see if it was successful. 200 means it was successful. 400 is error, and then 500 server errors and so on. So you can also get the JSON and then the next and all the other ones. So let's get back to the URL. The URL, we could also change it. So if you do a URL, change it to our YouTube channel, for example, and then that would be youtube.com/@MyWebUniversity. That's the handle. So this one, if when we do the r.get, you have to read it again with the request.get URL, and that one is also successful. So r.ok is there, r.status code is 200 also, and then r.text. Notice this one is a different page that is coming with all the YouTube videos that I have posted already. So this is there. And then similarly, if I say print r.content, and then you could get it in the byte format with HTML. And then you could write this one to a file, and then you get it. So there's a lot of things you could do with the request there. And there's other methods like Beautiful Soup, modules like Beautiful Soup, that you can parse it and do like web scraping and everything else. So at this time, let's go to NumPy, which we were originally doing it. So os.system, I'm going to clear my screen first. I'm going to say, let's get the NumPy module. In order to get the NumPy module, remember when we said import NumPy as NP, it says NumPy is not found. Right here, no module called there, because we haven't installed it yet. So I'm gonna just come back here and say, clear my screen and say pep list, and then find a string /I, and then say NumPy. Notice NumPy is not gonna return. That means it did not find it. So I'm gonna say pep install NumPy. This one is gonna find NumPy in the list of modules, and it's gonna install it for me. Then I up arrow the command, and this time I'm going to have the NumPy available. And this is the NumPy version 1.243. So now, since I've installed this one, NumPy 1.243, 1.24.3 is available. Now, if I just do the NumPy, it's gonna load it. So NumPy dot version, and then you can see the version is NumPy dot version. And then if I do a dir of an NP, you could see all the methods that are there, all the double underscore method and everything. One of them is double underscore version, to show you the version of the NumPy. So os.system, clear screen, and I'm gonna say NumPy.double_version, that's gonna show the same thing as os.system, and then pep list, and then find a string /I, and then NumPy. That is also going to show 1.24.3, and then np.double_version also shows you that. There's a lot of methods that are on NumPy. We can practice each one of them. Just to show you a few of them, let's just write the sine method and cosine and do some kind of a matplot and everything, and graph it and so on. So in order to do that one, I need to make sure that a couple of other methods are available. So our modules are available. So I'm going to say import matplotlib.pyplot as plot. If that one is available, matplotlib is not available. So going back to this command prompt that earlier we did here, we're gonna just do the same thing for the install. And instead of just saying install NumPy, we're gonna say pep install matplotlib. So we're going to try to install matplotlib in order to get the class pyplot. And then now it is loaded. Let's just do the find string. This time we're looking for matplotlib to see if that is there. And you can see here the version is there. Clearing my screen here, running the same command, you can see that the matplotlib is there, and 3.71. So here I just up arrow here. Now matplotlib is going to be loaded, and this PLT is there. So if I say type of PLT, show me PLT, it's going to say it's a module. And then if I do a dir on PLT, there's all methods of like plot and show and everything else that we can do it. Look how many of them are there. So os.system, clear my screen here again, so you can see on the top dir of NP, and there was a lot here. Okay, so now I'm going to just write some X and Y coordinate to just draw something. We can do a number of ways we can do it, but I was telling you that I'm going to use the sine and cosine. Let's do that one first. So we're gonna say X is equal. We're gonna say NP dot, let's create an array first, NP dot a range. That's an array that we are going to define into the value of X. We're gonna say, let's say from 4 to NP dot pi, and then we're gonna just say, let's start with -4 here, -4, and then 4 times np dot pi, and then 0.1 there. So what is this A range? You can specify a value, or you can start a value and then increment it to the last value and increment it by how many steps. These are steps. This is a start, and this is end, and then this is how many steps you want to do. And opposed to the range method, this one is a little bit different. So that's why you're going to have these value and the range method there. But it is kind of similar too. So I'm going to do that one with X. And now let's see if this X value, if I just print the X, notice how many values I created that one. So os.system, clear screen first, and then print type of X. So this X is a NumPy array, n-dimension array. So if I say print np.info and then get the X here, we can just say that, okay, it's a n-dimension array, and it has a shape of 100 elements. So the strides, and some of those ones I cannot read, but it is just in front of you. You can read it when you watch the video. So let me just go here. The X is there. Now we're gonna just do Y is equal. We're gonna do a sign of np dot sign of X. So this is going to just give us a Y value, and Y values are there. So if I just look at the np dot info of X, you can see that it is giving me that. And now if I get the Y, since they are on the same number of dimension, the number of elements, the shape is 166 or something, I forgot, is there. So np.shape, you can also print it here, the shape of X, and then the shape of Y. They should have the same value in order to plot them. So now we did that one. Let's just say plt.plot. We're going to say X comma Y. And then now we have created this object. We're going to just say plt.show and then see if the graph shows up. Right, really nice here that shows up the sine and cosine starting from the -4 all the way to 4, and then it's going there with that range. So obviously the X value on the A range, you can just change it from a start and a step and everything, and you will get a different graph here. But let's do another for the cosine also. I'm gonna close this one and then say z is equal np dot cosine of X. So we get the z. Now z is these values. So we say plot, and then we're gonna say X comma z. So this would be plt.plot. And then now say plt.show. This is the cosine values that start from 1 or something. So we can see that the graph is different, but in order to see those ones differently, maybe we can just create both of them together. So let's do plt.plot. We're gonna say X comma Y, and then comma, we're gonna say X comma Z, and then that would create that on plot.show, and now you have the X and Y values that are there. Notice the Y is starting from here, and then from 1, and then the X is starting from 0, and then from that one. But now we need to just label them correctly so we know the coloring and everything there. So we could say here, let's just close that graph here, and then we say plt plt.xlabel xlabel. So we're gonna say sign function. So whatever you want to write on that one, you could write sign. Maybe just write it as a method like function. That's good enough. And then this is module. This one has no attribute xlabel. The xlabel was mistyped, and let me correct it. Xlabel. That is corrected now, and now we have it. So I'm going to do the same thing with ylabel, and then we talk about cosine function here. And now say plot plt.show, and we do this one. Notice that now it's an empty graph because when we did the plot, we just did not do that one before the label. So we need to do the label a plot here to create that object, and now we see those ones. But let me see why the grid is not having it there. I'm gonna say also plt dot. Actually, it was showing for the. Let me close that one. You can see here. Let me just get the values. Okay, so I'm gonna do a few steps here. I'm gonna say legend. I'm gonna say this is gonna be a list. So I'm gonna say list of sign, and then also cosine. Okay. So we did that one, the legend, and then the plot dot show is not going to show because we got the X, we get the Y, we got the Z. So I'm going to say plot dot plt dot plot X comma Y, and then also comma. Let's put a color also here. We actually do have two different colors, but you could add a color also with like another comma and then color like red or B for blue and so on. So X comma Z, that is there, plot.show. And let me see why the legends are not showing up here yet. The order is important, the way we create the plot there. The legend we had to do first there, and then the X label. Let me just do the X label here. So that's the Y label. Did I type anything wrong there? Y label plt x cosine, that should be okay. And then similarly text 0 this cosine, and then we're going to say x, and then we're going to say sine, and then plt dot plot x comma y, and then plt dot plot x comma z, plt dot show. Okay, so some of the informations are not displayed here. I'm not sure why. I'm going to double check on it. And we could do that one on Jupyter Lab also. I believe the order that is a matter. So here, plot x and y. Let me just say plot dot grid is true. We're gonna create a grid for it, and then do a show here. So the grid shows up, but then now the graphs are not there. So I'm gonna do a plot x comma y comma x comma z, that one there, and then plot dot show is gonna show, but the grid disappeared. So on the order that we started off with the XYZ coordinate, we already did that one. Let's just make sure that those values are not inside the, we actually do have the value, X is there and Y is there and Z is there. And then I'm gonna say plt dot legend. Let's do from the grid first true, and then plt dot I'm gonna try the first XYZ here, and then I'm gonna do the legend. The legend is there. We already closed that one, and then the plot of we need to do one more thing here. The Y label is good, and then the X label sign and plt dot grid, and we're gonna say true, and then plt dot show. There you go. So the order was important. The order that you have to do, you are doing the plot first, then the legend, and then the X and Y. If you didn't do the plot first, that will not add these ones. So now you can see sine is there and cosine is there, and the sine for the x-axis and cosine for the y-axis. And then the values, you can put anything that you want. And now we're gonna have a title also. Let's see if the title could show before that one. Before we do the show, we're gonna say title, and then we say sine and cosine function, and functions. We're gonna do a graph of sine and cosine as the title. So graph of sine and cosine function, and that's the title. Did you mean title? So the title, I missed another T here. Sorry for the text, maybe too small from reading it from far away. And then now, and the title got created, the text. So we do this and then says that. But again, you lose the other objects. So in order to get everything else, we're gonna go up arrow on the plot. You just do this one first, and then you do the grid, and then you go the legends. The grid is fine, and then the X label. We're gonna do the Y label. Okay, Y label, and then the grid. Maybe I should just type it, it's faster that way. Grid is, the legend is there, and then we say, and then let's say plot.grid, and then we say true. So true is a 1 and 0 is a false. And then we also say plot.title, right there, title, and then plot.show. Now we should see everything together. And then we do. And so this is showing the graph and then the sign function and everything. So this was a demonstration of using NumPy plot and NumPy method with matplotlib, pyplot methods that are available, and you could just do this. And then what else you could do? Let's say on some kind of math stuff you do with a list or something. Let's just run some operating system command here. So we could say os.system, we're going to do a clear screen. And then here you could just say, let's just get the IPython information to see if you can just execute. Inside here, os.system, you could say, let's just run interactive Python, IPython, and then just see if that executed. Actually, it did. So now we're inside the IPython. And then now notice that aliases is going to show you a list of aliases. If I just say clear screen, it's going to clear a screen. Alias, I could type in clear command, does not work because that's a Windows, I'm sorry, Linux and Mac. So for this one, as a Windows, it's a clear command. And then if I just say import OS module, you could do that on the same thing here. Inside here, you could call Jupyter Lab, or you could run say system, let's run the system command directory, and then run the directory, and then run the command like 3 command to get a list of the things that are available. Obviously, you have to close it, and then you get that. And then just run the host name. To get that one. So if you see algorithm, that's the name of the host, and you could clear the screen, it's the same thing. Now, since we did import OS, if I say dir of OS, you see all the methods that are available for me. So the clear screen, again, it will clear it. I could also do dir of OS. When I did this one, I don't need to just do this one. I could just type in clear screen, because I'm inside IPython. I don't need the help of OS module, the os.system method. I don't need it. I could just type in the command, and since one of the command is clear screen, I could do it. So ls command is like a directory command here. As you can see here, a list of the lists that are available on IPython. You could get this one, whether you run the IPython inside here or exit out. Now I'm back into the inside the Python idle. So I could say os.system, and I could say go ahead, run Jupyter Lab. So normally you want to run it inside the Windows operating system or Mac OS X or Linux, but I'm just showing you the powerful feature of Python itself, that you can just do these kind of things. Now it's gonna open up a browser, and then it says choose your browser choice. I'm gonna open up a Jupyter Lab on port 8888, and then now I have Jupyter Lab here. The directory that I was in here, it is all showing those directories, but if I'm not interested to see all of that, I could just see in Jupyter Lab here. And inside Jupyter Lab, I can run other commands like on these modules that's the kernel. So if I just say, show me a list of aliases, I can run a command like dir just by putting this bang in front of it, and I could just run it and notice that's the same thing. Now, I forgot to show you some more things on IPython before I jump in to Jupyter Lab. Same feature that are available on IPython is also on Jupyter Lab. So let me show you the IPython, for example. I'm going to open this command prompt that was already open here somewhere. So I'm going to do alternate tab to just look at some of these command prompts. I open a number of them. I'm going to just exit these ones. I don't need too many of them. So let me just go to this one, for example. We were looking at this directory, clear screen. I'm going to say IPython here. So if I can get into IPython here and then run these commands, aliases, and everything, and then just work with it. Remember that list of features that are on IPython is similar what is on Jupyter Lab. So I could say percentage ls magic, and then a list of magic or that are available for line magic as well as for cell magic. These are the commands. For the cell magic, you can write HTML code, you can write the JavaScript, you can write Bash if you're on Linux or a Mac, or you could run it on the Windows command prompt. You can do a for statement, if a statement, anything. You want to write Bash scripting, you could do that one. You write JavaScript, you could get it on the, you could go to a section version of Python, Python 3. All of these one, Ruby, all of them are available for you. So in addition, there's a list of line magic that you can just do these ones. We showed you already the alias and clear screen and directories and other ones, the CDs and everything. In addition to these lists, you can also use one bang or exclamation and run the operating system command. So if I say find string, let's say I'm going to just say dir of, or just say run Jupyter Lab or Jupyter Notebook from here. I could do that one, but I want to just do one more command here. So ls was showing by default, was part of an alias, and then dir is the command equivalent to this. So if I say I'm on a PowerShell, I can even start PowerShell here. Now I'm inside PowerShell. So inside one, you can get to the other one. Now, if I say get item from the current directory, or get item on the current directory with everything that's there, with the files that are there, get child item. Let's say get item. If you just do this one and then C colon slash, it will just give you the C. If I say get item and then C colon slash start, and then it's going to show the files also. So get item from the current one, C colon slash start, will do the same thing here. And then some other methods you could do that, like get the process there, get a child item, or get, let's say, get dash help, get a child item. You can see that get child item, ls, and dir are all returning the same value. So whether you type in get child item or ls or dir, ls will give you that one, dir will give you that one, get a child item will all give you that, or get GCI as an alias for it. So you will get those information. But then I'm inside the Python interpreter, and then I could just do a lot of commands here that are PowerShell command. Get dash help, get dash process, and then get dash service, get all of that one are available here. So if I exit out of this one, I'm now back into PowerShell. I mean, inside the IPython. So here, if I say import OS, and then let's clear my screen here, I could do a clear screen here like that, or I could type in clear screen, would be the same thing. Or I could do two of them, cd to a directory that I could say make dir test1. Now I created the test1. Now I could say cd to test1. Now I just cd to that one. If I do a dir command, that directory is empty. So if I just say dot dot, and then let's just go back again to PowerShell, see what we did here. So I'm going to say just go to PowerShell. And then now it's inside PowerShell. It did not understand this one. Let me just make sure I don't have typo. PowerShell. It was not typo, so I needed only one bank, and that would take me there. So if I just say in directory here, and the test1 was created there. So directory /o:\d, that is not the syntax of that. I could just open up this and say bang cmd. That is going to open a command prompt. Now directory /o:\d is a Windows command. It will understand and sort it there. So the test1 I just created there. Directory of test1, it is just empty. If I just want to remove that directory, I could go out of this one back, and I'm on Python. I could say rm dir test1, and then run this one. Now, if I say this one, go back to CMD, notice that test1 is not there anymore. I exit out of this one, that's good. So you can get to run operating system command. You can also do os dot, let's clear the screen, os dot, and then now if I just use the tab, it gives me a list of all the methods that are available and all constants that are available inside IPython. The same thing is true about Jupyter Lab. But if you want to get it on idle, you have to use something like code, Visual Studio Code, or PyCharm, some IDE, integrated development environment, to get that kind of interface. Interactive Python and Jupyter Lab is pretty friendly on that one. So like you could say os.get, and as soon as you just say get, and then you could tab it, you could say the method that are available for get current working directory, where the directory we started off, get parent process ID, all of those ones are there. Get process ID of my IPython program, and get login. So notice as soon as you do a tab, it's going to just provide the rest of it. If you say os dot, and then you just type in sys and press tab, notice the system is there and sys is there. So whichever you want, os dot tab everything that is available. Kill command and all the other ones, environment and get environment, get env. So os dot get env, normally if you just wanted the path, you could just get that information. os dot user name. Let's see if that one is there. Username. Yeah, it's there. User profile. So since it's on Microsoft Windows, some of those things are available. Like get env, and instead of this env, you could say bang, and then use the set command. Set command is the show you all the environment variables. You could also say bang and then os.system, and then say clear screen. I'm sorry, run the set command here. So you could do that one also, os.system. Actually, for that one, you don't need the bang. You could do this one if you need the bang, you just have to run this command like so. So clear the screen, and you say bang, and then set command. That will do it. Okay. So this is everything that I did here with IPython. You can also get it with inside Jupyter Lab. The only difference is that Jupyter Lab is provided you on a web browser, so you can do it on a web services, and then you just started with Jupyter Lab like that. And then if I just am running it, I just go to the browser, and then on the browser that I started, let me just make sure that the browser that is already open for it. I don't want to go to open too many of them. And then let's go to this browser here. We're already on Jupyter Lab here. So with Jupyter Lab, if I say run this command of 3 command and just run it here, and then at the same time, let's just create a list here. We say I'm on a Windows machine. I'm going to create a commands as equal. I'm going to just create a list of these commands, directory command, and then 3 command, and then host name. Just those 3, and then you could do more. So let's just do one more for calculator, and one more for Microsoft WordPad, which is write.exec is the name. So you could do this one, and now I could say, and this output doesn't make any sense at this time. I'm gonna just write more code here. So when we run it, we are having a different things, different output. So for CMD and commands, then just what do you want to do with it? I'm gonna just run and instead of, I could run the os.system and then run the command here, CMD, and just as simple as that. Since those commands are commands that I want to execute, I could just do this. And then let's see what it says, a string literal, right. So yeah, so this is a list here. Somewhere I did not close something. Let me see. Under, then 3, then host name. Yeah, host name I did not have. I started embrace here. I mean single quote. So that was missing. Now we have done it. It should work. Let's see what is this time. It says something os.system command. OS is not defined. Yeah, we did not import OS. So in the first line, what you want to do is import OS first, and then we say import OS. And normally, if you had loaded in the previous cell, it would have worked. So now this is the write, this is the calculator, and then the dir command and other outputs are already shown somewhere. Let's see where the details are. I'm gonna take this write out, calc out, see if those are the one that I want to run only as output. Okay, so would you like to receive official Jupyter news? So this is just an advertisement. I'm going to just instead of the os.system, I'm going to go on this other cell, and I'm going to just say os.system. I'm going to run the dir command to see why I'm not seeing the output here. Sometimes Jupyter Lab could hang, and then os.system, OS is modules as no attribute system. Maybe I mistyped system. System. Let me rewrite it. os.system and dir maybe I missed that. So system, yeah, I'm missing the T there. I thought that I wrote it correctly, but let's see. Yeah, so this one, notice this one is returning this 0, meaning that the command succeeded. Because the system module, even for the other ones, it was just because it was executing the write in other ones, for these other ones, or text, it just returned a 0, meaning successful. So in order to do this one, and instead of writing something like this, you could just say, since OS is already loaded, we could just say for CMD and commands. This time we're going to use a different method, and we are using stream to open the os.process open or pipe open, and then we're opening the command, and then we say output is equal, say a stream dot read, and then we print the output. This time we should get the result, and we don't need the value of 0 to show up here. So somewhere output, I mistyped it. So I missed the OPT. I have to correct some of those typos, otherwise you're gonna not like the videos. So so you can see now I corrected it, and it is typed correctly, and it produces the output of those commands. And the last one was algorithm, the name of the host name. So here you can just add the list of the commands. Say, for example, let's do a command like a longer command to see check, not check actually. Let's do ipconfig /all. We get all the parameters of the network here. It's just something that you shouldn't see, but it's okay, because these machines, I am not having it online all the time. I only make videos and then I turn it off. So it's safe. When I run this one, it's gonna just have this. And now this time I'm gonna run this, and this output of this cell, now I have the ipconfig here, output here, after algorithm, okay? So you can do as many things as you want for this one. And then inside here, if you just say what other features are there, I could just delete these cells and just start all over. I could just say, for example, let's say import, do an import sys module, and then sys.os, sys.executable. Notice that this one is also going to show you the same thing that we got it from Python, and then sys.path is going to give you the same kind of things. And so at this time, let's just what else we could do for this one. I don't want this video to go forever. You could do aliases, percentage alias. Actually, alias itself is going to give you a list of aliases that are there. So when you do a clear screen, this will just does not mean anything on the cell, but on IPython and idle, it means something. The dir command itself means run the directory command, and then it says this is a function. But some of the things that are available here is also, like if I say import, we did import sys, so let's say sys dot, and you could see all the methods that are there. When you press that, you could get like argv and all the other ones. So if I just say sys.ps1, get me the ps1 or value, it is there. Sys.ps2. Notice that the prompt shell 2 and prompt shell 1, or what is the Jupyter that you get there. So this is pretty good. Import OS, and then say os.get current working directory. Those methods are all there. So os dot system run the set command, and then at the same time, like if I just get it into a set, Notice this one just successful. In order for me to get it, I say create a stream first and says os.process open, pipe open, and then run the set command, and then say output is equal. I'm just creating one character there. Stream.read. And this method, you read it, and then now print output O. So I don't have too much to make a typo, and then you can still get the job done. So this is what you can do with Jupyter Notebook. There's a lot more. I'm going to make more videos for you. Please make sure that you go to our YouTube channel, which is MyWebUniversity free education videos. I have posted a lot of videos already, and you're welcome to just like and subscribe. And if you haven't subscribed, I would appreciate if you guys show your interest. That way, I don't waste my time, and I just make videos that is gonna help and fulfill your needs. My job is to just make these videos so I can transfer the knowledge, and then you guys' job is to learn and then do good at your school, at your work, and do better. Whatever you do, you can enhance it always by learning it from these online videos. All you're getting is free education videos. You don't need to go to universities and pay expensive tuition. All the books, everything is online for you. I have just done like this video, which is about 6,600 technical documentation for Linux Ubuntu version, for example. This one is for PowerShell, and then about 1,394. There's for Windows, for 66,000 technical documentation I have on this website for Solaris operating system, Linux operating systems, Mac OS X, Windows PowerShell, and then Windows Help, and a lot of other Python and C, C++, and other programming, Apache Web Server, Awk, stuff that you can just get like ChatGPT, and get how to stop hackers from hacking your site or something. There's a lot of documentation here that you can just enjoy and start learning. So please subscribe, and then it will help you a lot. And that way you get all my videos right away for you when I posted something. Take care. God bless you all. Bye-bye.